let us start this lecture with a thought process. Sin cannot be a therapy for sin. Generally, most of us think in the manner that we will have to use the tit for tat and take revenge, but that is not the case. We should keep that in mind. Let us recall what we learned in the last lecture. In the last lecture, we initiated a discussion on the liquid propellant rocket engine, which happens to be very important workhorse in modern time because of fact that it is quite compact and it can have a higher performance level as compared to the solid propellant rocket engine, and beside this it can be throttleable easily. And we have also seen that even the V2 rocket engine, which was designed and developed before the Second World War, and that shows that it is quite complex in nature. And later on we also looked at various kinds of engine, and that is the monopropellant rocket engine and bipropellant rocket engine. And monopropellant rocket engine generally used for applications wherever there is no binding of having higher thrust and higher specific impulse, particularly in the deep space, and it is quite simple in nature as compared to the bipropellant rocket engine. And bipropellant rocket engine is quite complex in nature, and we looked at the systems, its schematic, and also looked at a cutaway model of the typical liquid propellant rocket engine. And it is having several components and systems, and if we can recall now, that it is having the injection system, propellant feed system, ignition system, combustion chamber, and rocket nozzle, and also the cooling system. So, these are really quite a bit systems we are having, and each is having several components and quite complex in nature. It is quite challenging and to design and develop a liquid propellant rocket engine. When you look at the solid propellant rocket engine, is quite complex in nature. So, today we will be initiating a discussion on the injection system. When you talk about the injection system, it is basically about how we can inject the fuel, liquid fuel, into the combustion chamber such that it can be atomized easily, and not only it will be converted into the series of droplet or an array of droplets, but it is also has to be vaporized and mixed properly such that the combustion can take place to have a high temperature and pressure gas, and which can be expanded to in the nozzle to produce the thrust. So, therefore, injection system plays a very important role and for ensuring the efficient use of the propellant in generating the requisite thrust. Question is, what are the main functions of injection system? So, main function of injection system is to deliver a requisite flow rate of propellant, that means either the fuel or oxidizer or the both, and ensure good atomization and mixing in the combustion chamber, and it is also mean to maintain proper local mixture ratio of fuel and oxidizer in a combustion chamber, such that the hot spot will not be there, or there will not be any sudden pressure rise that may lead to the combustion instability. And also the injection system is to design to maximize the characteristics velocity for a given combustor chamber length. And as I told earlier and shown you in a schematic, that the propellant, particularly the fuel, is used as a coolant for cooling of the combustion chamber and nozzle and also the injector face. And injection system must be designed in such a way so that we can have a higher turn down ratio of the combustion turn down ratio. And a turn down ratio means basically the ratio of maximum to minimum power that the engine can have. So, therefore, the injection system plays a very important role in dictating the performance of the liquid propellant rocket engine. Therefore, this is very important. And as I told that it must be designed in a such a way that it can be fabricated and maintained very easily. Otherwise, it will be difficult to really have a injection system which will be difficult to manufacture, and also maintenance is a big problem as the port size or the hole size of the injectors are quite small. So, question arises, what are the main components of an injection system? So, it will be having two components, one is your distributor, other is the injector head, of course, in which the atomizer will be placed. And so, let us look at a distributor along with the injector heads, and injector head with the hole is basically the atomizer. If you can look at, this is your injector head which will be carrying these holes or the orifices. These are orifice which will be nothing but your atomizer. So, therefore, it will be having, if you look at, this is having atomizer, and the propellant there is a liquid propellant which will be passing through this into this orifice or the injector heads, and then it has to be made this distributed in such a way that fluid will be coming toward that, it will be passing through this in a proper way, so that the uniformity of the flow through each orifices will be similar if not same, so that the atomization process will not be affected. And this is your schematic. What I could say, there should not be any short circuiting, that means it is not that it will come over here, there might be baffle which can be used, is not shown here, it should not come and hit so that the higher velocity will be coming through this nozzle, that is not really called for, but rather it will be distributed properly. And if you look at this injector head which I have shown, this is the actual photograph, you can see these are the holes which is orifices, these are the orifices or atomizer, right, and which is having a certain circle, peace circle it is being used, and this is your feed line, the propellant feed line which comes over through that, and there is a on the below of this injector head there is a distributor which is not shown in this photograph. What is atomization? Atomization is a process by which the bulk liquid is converted into arrays of droplets, what we call spray. A question might be coming into your mind, why we need to have this atomization? Why not we burn the bulk liquid itself? Keep in mind that the one can burn the bulk liquid, but however, one has to vaporize the liquid, and also the amount of vaporization and of the liquid propellant will be dictating how much the energy will be released per unit area per second. So, that therefore, we need to convert this bulk liquid into the droplets of smaller diameter, such that the surface to mass ratio will be, surface to volume ratio will be really higher. The higher the surface area, the better will be vaporization, whereas the mass of propellant is being burned will be dictated by the volume. So, therefore, it is better to have a smaller droplets, such that the higher surface area will be prevail, and due to higher surface area we can have the higher rate of vaporization of the propellant, and once it is vaporized it can mix with the other oxidizer and such that combustion can take place, provided it is ignited properly and other thing. So, therefore, it is very important to have a better atomization. Let us look at what are the basic processes involved in atomization or during atomization. So, let us look at a tube in which you are having a liquid which is passing through that, and then what will happen if it is not injected at a high pressure, then you can see that the liquid will be coming over here due to the gravity. Because of that, it will be just on the orifice or the hole or the exit of this tube. This is your liquid envelope which will be coming, and once it will go, then because of gravity, then it will be little bit down, and the surface tension force which will be overcome by this gravitational force. And then it will be separated out, as you can see, and thinning down due to the thinning down of the liquid surface, and when it is pulled by the gravity. And keep in mind that as a result there is a satellite droplets, and if you look at this will be, and this will be this thing, then after that it will be coming over here, and then it will be thinning down kind of things, and this will be coming to that, and that will be a droplets which will be coming over here, and this again it is being formed. So, this is known as satellite droplet. And the question arises, what is the dripping mechanism? This is just about dripping of the liquid, and this, if you call, this is basically dripping of liquid, and which is very common in nature. So, the gravity force exceeds the attaching the surface tension forces, and the surface tension which will be acting over here, and then that is separated out, and satellite droplets are being formed, and also the bigger droplets. And question is, what do you mean atomization? As I told, atomization is the process by which the bulk liquid is basically converted into arrays of droplets. Let us look at little bit further and see what is happening. If we take an orifice, and through which you are basically passing this liquid, or a pipe with a hole, and the solid jet is coming through that. This is your solid jet of liquid, and which is not really affected by the forces which will be acting over here, and then you are just passing through this pipe, the tube, and it is straight. Of course, it is very difficult to get and when this it is also difficult to achieve the solid jet in true sense, and this solid jet of liquid is being used for as a fire extinction. That means, you can use the water as a fire extinguisher and then can really use it. But for atomization, this is not the case what we should desire to have. So, therefore, we will have to, we are not interested in that, but what we need is that we will have to disturb the liquid such that it will be disintegrated very easily into the droplets. That is the requirement for better atomization. So, for that what we do, we put this liquid at a very high pressure and which will be passing through this orifice or the hole. This is your if you look at, this is your hole or the orifice, and keep in mind that there is a lot of ripples over here and this bulk liquid is disintegrated, and you can see in this diagram, and question arises what happens, why the solid jet of the liquid or the jet of the liquid remain intact and without really any distortion in the liquid, because of the fact that resisting forces are greater than the disruptive forces. If you look at what are the resisting forces, one of course, we know it is the surface tension force, and another is of course the viscous forces. If it is a viscous liquid and the surface tension forces are there, then you can have really like this. Of course, you will have to design properly so that it will be coming as a solid jet of liquid, and greater than disruptive. In this case, the inertia force is one of them. Of course, there will be aerodynamic forces, there will be also the turbulence which will be generated. And in this case, when the liquid is distorted to form a spray, right, then what will happen, the resisting forces will be weaker as compared to the disruptive forces, and then when the resisting forces are greater than the disruptive forces, there is no atomization. That means, that is also true for a country, for a family, for any other things to keep their identity, keep it together. So, when the fluid elements are together, it is like a solid jet of liquid, it is not disintegrated. And when we are having subjected to the disruptive forces which will be trying to destabilize, then and we can't really resist, therefore, we get the atomization. If you look at today, our country is basically suffering due to the cultural invasion. We couldn't really resist, but however, in case of atomization is basically should have a higher disruptive forces as compared to the resisting forces. So, therefore, we can manage to atomize, and then surface area will increase and the droplet size will be reduced. So, therefore, we can summarize that breakoff of the bulk liquid into the droplets into the spray can be possible only when the disruptive forces exceed the resisting forces. So, that is the basic principle which really one has to look at it, and one can use these forces to their advantages. So, let us look at what are the processes involved during this atomization of liquid. So, if I consider a slit over here, slit means basically if I look at, this is your slit, this is your slit through which the liquid is passing through that, this is your liquid. And when it is and this is slit length, and this is your slit width. So, and thinner it will be better, the width of the, I can say this is W, width of the slit, and when it is forced through this slit, then we get a 2-dimensional slab liquid surface, and it undergoes a oscillations and the thinning. This is the thinning of a liquid surface, and it is subjected to the oscillations and undulations, and such that it will be thinning out somewhere, and then it will be separated from the main bulk liquid. This is your bulk liquid surface, and then it will be separated and form a rod in this example, and this liquid rod we call basically again subjected to oscillation and thinning down because of this gravitational forces and then other disruptive forces, and such that there will be thinning down of the liquid, which will be thinner. This is thinner area. The thin surface, and as a result this will be separated out much thinner, and this is the ligament which is their form, ligaments. That means, this is basically when the ligaments are formed from the bulk liquid, we call it as a basically primary atomization, and due to the surface tension the droplets are being formed and droplets. So, and these droplets again subjected to aerodynamic forces, and then others they may collide each other, and also subjected to other turbulence of the flow, such that it may be disintegrated again, going through various processes which I am not going to discuss, into smaller droplet, that is known as secondary atomization. So, if you want to really summarize the processes, this will be, first is the thinning of the liquid surface, or we call it basically stretching of the liquid sheet or the jet. This we are considering a sheet. However, when you consider an orifice and the liquid is passing through that, then it will be really passing through a surface, and then it can be conveyed, and this is a liquid jet which will be coming liquid jet. So, therefore, and this can be undulated, we will see that it can be this growth of the waves in the sheet. These are the waves in the sheets, and then because of this oscillation of the surface, there will be thinning down of this liquid surface in some places, and it will be separated from the bulk liquid as I told, and as a result there will be ligaments being formed, and the breakup of ligaments are also again will be taking place, and droplets are formed. So, therefore, we will have to look at that how it is really being done, and it is quite a complex process, and as I told there will be primary atomization, where the ligaments are formed after getting separated from the bulk liquid, and there is also a secondary atomization, where the droplets which are formed due to the surface tension from the ligaments, that is further disintegrated and shredding off, so that the smaller droplets are formed. And keep in mind that these smaller droplets and can also coalesce and form a bigger droplet, particularly when the inertia force and the aerodynamic forces will not be there or will be minimized. So, this disintegration of the ligaments from the bulk liquid is dictated by a non-dimensional number which is known as the Weber number. It is basically the inertia force. If you look at this is inertia force divided by the surface tension. Keep in mind that rho is the density and dj is your diameter here. This if you look at, this is your dj, the jet diameter, dj is jet diameter, and the Vj is the jet velocity, and sigma is your surface tension force, And keep in mind that this Weber number should be greater than 1. That means, the inertia force will be higher as compared to the surface force, so that it can be disintegrated. You can conduct an experiment just to have a feel for the Weber number. What you can do, you take a liquid and just allow it to fall on the floor with certain small distance from the floor itself. For example, if I take a floor here and then you are just putting a liquid here, you can see there is a surface. This is your liquid surface or liquid seat, you can say liquid seat. And as you distance, this distance is let us say h, and when you increase this distance, you will find if it is now let us say h1, which is higher than the h, then you will find that there is some disintegration of the liquid which is falling away from the liquid seat. As you go on increasing this distance between this tube through which you are supplying the liquid very slow manner, then you can see that the more droplets or more separated liquid seats are being formed from the major liquid seat. So, therefore, this is the you can see that Weber number. However, here in this case the velocity of the jet is having some substantial, but you will not taking care of the viscosity, and therefore, we use another Reynolds number known as Reynolds number, rho Vj dj by mu. This is your viscosity of the liquid. Now, that is being not taken I mean like in this ratio. So, when you talk about this, then basically we can use another number by combining this, that is known as Ohnesor's number, and this is number which is a non-dimensional number and is a ratio of basically the viscous force divided by, if you look at, it is the inertia force, inertia into surface tension. So, this is a very important this thing, because this is also known as stability number, and we will be discussing more about this Ohnesor's number in the next lecture. Thank you very much.